In this video, I will be going through the AQA specimen paper from paper 2, which is the higher tier, and the topic is on forces. Question number 3. A swimmer dives off a boat. Look at figure 2. What two factors determine the momentum of the swimmer? So if you look at the equation for momentum, right? Momentum equals mass multiplied by the velocity. So the two factors that affect the momentum of the swimmer is going to be the mass and the velocity. So that will be the mass and velocity. What is the unit for momentum? So how do you work out the unit for momentum? We know the equation for momentum is rho equals mv. So the unit for mass is kg, and the unit for velocity is meters per second, which is going to be the second option. Next question. 3.3. The boat was stationary. As the swimmer dives forward, the boat moves backwards. Use ideas of conservation of momentum to explain why the boat moves backwards. So I use the idea of conservation of momentum. What does that actually tell you? Right? Conservation of momentum states that total momentum before he jumps off should be equal to the total momentum after. Before diving, total momentum of boat and diver equals 0. Why is that? Because it's not moving. So after diving, the diver has forward momentum or to the right. Therefore, the boat has an equal backwards momentum pen's failing me, sorry, backwards momentum to the left. So the reason the boat moves backwards is Because the diver is moving forward, the boat has to move backwards in order to balance the momentum produced by the diver. Question 3.4. Explain what would happen to the motion of the boat if there were more people on the boat when the diver dived off. Now, if there were more people, then the mass of the boat would have actually increased. So, the boat will still move backwards, right? The boat moves back more slowly, because we are trying to explain, we need to give a reason, because there is more mass which is referring to the mass of the boat, but momentum remains the same. Next question. Question 3.5. The swimmer's speed increases as she swims away from the boat. The swimmer has a top speed. Explain why. Top speed basically means the maximum speed, right? It's very similar to think of an object falling through air, like terminal velocity, right? The reason she would have a top speed is the force produced by the forward thrust would eventually balance off by the drag due to the water. So when these two forces are balanced, she's not going to speed up anymore. Initially, the drag would be less, and as she speeds up, the drag will actually slowly increase till it balances out the forward thrust. So let's write the answer. First point for 5 marks. There is a drag force as she swims. Point 2. As speed increases, so does the drag force. So she accelerates less. Point 4. When the drag force equals the thrust force, the swimmer reaches top speed or terminal velocity. And I can give a last point. Since resultant force equals 0 at that stage. Because the resultant force is 0, she's not going to speed up anymore. Remember Newton's laws? There has to be a force, Newton's first law. So this question links to Newton's first law of motion. If you don't know what that is, make a note underneath it here. And it also links to the concept of terminal velocity. That's the end of the question, and that's the end of the video.